Hi, my name is KHAIRUN binti ZAIDI and my matrix number is 2024-296-826 and I'm from class CDCS1102E.
Hello, my name is ADILA with ABDUL AZMAN. My student ID is 2024221188. Right, I am from CDCS1102E.
My name is MUNIRAH binti YACCOB. My student ID is 2024283526 and I'm from class CDCS1102E.
Introduction. Have you ever thought about how we can understand change in our everyday life, like how fast a car is going or how the water level decreases in a tank? This change can be measured and analyzed using a mathematical concept called derivative. They play a crucial role in many fields and significantly impact our daily life in unexpected ways. So let's get started.
Differentiation is the process of finding the derivative of a function with respect to an independent variable. It is used in calculus to measure how a function changes per unit change in its independent variable. Let's say the rate of change of y per unit change in x is given by dy over dx. If the function undergoes a very small change near any point, the derivative is defined as lim h approaches to 0 f multiplied by x plus h minus fx over h. There are 6 techniques of differentiation, which is power rule, product rule, quotient rule, chain rule, implicit differentiation, and linear approximation.
Question 2. A. Y equal to 3x power of 2, set x plus 2. To solve this, I use the product rule. Since there is a product of the function, the first function, u is 3x power of 2. Its derivative, u prime, is set x. The second function, v, is set x plus 2. The derivative of set x plus 2, which is v prime, is set x plus 2 times x plus 2. Applying the product rule, dy per dx equal to u v prime plus v u prime. Substituting the value and expand. So the final answer is dy per dx equal to 3x power of 2 sec x plus 2 times x plus 2 plus 6x sec x plus 2. Next question is B. Y equal to 4x plus 2 divided by cos x. This is quotient, so I use the quotient rule. Let u equal to 4x plus 2, so u prime equal to 4. Let v equal to cos x and v prime equal to negative sin x. Using the quotient rule, dy per dx equal to v u prime minus u v prime divided by v power of 2. Substitute the value and expand and simplify the numerator. So the final answer is dy per dx equal to 4 cos x plus 4x plus 2 sin x divided by cos 2x.
So for question 3, we are given y ln 3x minus exponent power 2x plus 1 minus 10 for y equals to 0. So we need to find dy dx using implicit differentiation. So as you can see, I broke the equation in 3 parts, which is y ln 3x, which is highlighted in green, exponent power 2x plus 1, which is highlighted in blue, and the tan for y, which is highlighted in green. So for the first part, we need to use product rule because there are 2 functions, which is y and 3x. So we need to apply the product rule. So product rule, we need to use dy dx equals to u prime v plus u v prime for the formula. So we need to find everything. So for the u, which is y, and so u prime is going to be dy per dx. So v equals to ln 3x and v prime will be 1 over 3x multiplied by 3. And then I simplify it into 1 over x. So after we got everything, we are going to apply it into the formula. So it's going to be y multiplied by 1 over x because it's v prime u and v prime plus v and u prime, which is ln multiplied by 3x multiplied by dy dx. So that's for the first part. We're going to move for the second part. So for the second part, we are going to use the chain rule because the exponent is not just 2x, but it's 2x plus 1. So we're going to use the chain rule formula, which is dy over dx equals to f prime gx multiplied by g prime x. So exponent over 2x plus 1 will be exponent power 2x plus 1 multiplied by 2 because we differentiate the power, not the whole thing, just the power. And then we're going to multiply it to e, so it's going to be 2e powered by 2x plus 1. So moving on to the third part, which is the temp for y. So we need to use the chain rule it's because inside the tangent is for y. So y depends on x. So we're going to use the same formula, and then we're going to get sec powered by 2 multiplied by 4y, and then we're going to differentiate the 4y, and then we're going to get sec powered by 2 multiplied by 4y multiplied by 4 dy over dx. So that is the end for first part, second, and third. But we're not done yet for the question. So stay tuned. Alright, so after that, we're going to combine everything that we differentiated parts into one equation, and then we'll get the helpful equation that I got. And then we're going to move the term involving dy over dx to one side, and if the equation doesn't have any dy dx, we're going to move it to the right side. Right. So after that, after I simplifies it, and then I will get negative y 1 over x plus 2 exponent power 2x plus 1 over ln 3x minus 4 sec over 4 sec power by 2 for y. So that's the answer.
Question 4. Use linear approximation to estimate the value of log root of 18.99 minus 2 square root of 18.99. So we use formula linear approximation, which is fs equal to fs naught plus f prime s naught delta x. First, we define the function fs equal to 4 root s minus 2 over square root s. Then we differentiate s. We get x power 1 over 4 minus 2s power negative 1 half. Then we find the derivative, we get f prime s equal to 1 over 4s power negative g over 4 plus 2s power negative g over 2. Then we let x equal to 18.99 and s naught equal to 81. So delta s is the difference between s and s naught. In this case, delta s equal 18.99 minus 81, which is negative 0.01. Then using the linear approximation formula, we estimate f of x as f of 81 plus f prime of 81 times negative 0.01. So we get 25 over 9 plus 35 over 2916 times negative 0.01. So we get the answer is 2.7776575. In this question, 1 in 3 decimal place, so the final answer is 2.778.
In conclusion, differentiation helps us understand how things change. We use rules like product, quotient, and chain rule to solve problems. Implicit differentiation helps when x and y are mixed. We also use linear approximation to estimate values. Overall, differentiation is useful for solving many type of problems.